Okay, welcome everyone. We are just starting our second lecture on Introduction to Programming with R. Let me double check. So I want to share with you, well, first of all, let me know please if you have any questions from lecture number 1. Also, if you guys can hear me. Or better, if you cannot hear me, you should be able to see me now and listen to my voice, I hope. So first of all, any questions from last Tuesday, where we basically discussed a little bit of the course and a very lightweighted or basic introduction to R. There was something, I take this a few minutes while we ask you if you have any questions, so you have a chance to post them in the chat, either in the Zoom meeting or in the course website. But I had these minutes to mention something that is quite important as well as part of the course. I may have mentioned this, but I didn't go into much detail. But so I hope that you can, let me see, double check this. So you should be able to see my browser showing the course website. For some reason I cannot see the green screen around the window that's supposed to be sharing. So if for whatever reason you are not seeing the screen, you're not seeing the browser and the introduction to programming with our website, please let me know. The thing I wanted to show you is this forum. So if you click on the forum on the top menu, you go basically into the online forum of the course, which I believe is a really nice tool, especially in this modality that we are hosting the course, because it allows you to ask questions and post comments and basically chat or have a communication, a conversation between all of us. The other very interesting thing that the forum allows you is to subscribe. So as you can see here, for me it says unsubscribe because I'm already subscribed, but as soon as you click on forum, you can click on what it will say subscribe, and what that will do is it will allow you to receive email notifications every time that someone posts something in the forum. The other thing is you will have to click in course forum, of course, and then it will say, okay, in this case, there are no posts in the forum. Now, one thing I will recommend to do is every time that you have a question and it's not following a conversation or something, you click in new thread, and then you can write something like say, welcome to BCH 2024. This is just an initial post to welcome everyone. Okay. So in that way, it's easier for everyone to follow the threads and the conversations and whatever is going on. So if we put new thread when the topic change, of course, this is something that is on the same page or on the same topic, then it shouldn't be a problem at all to continue the conversation and reply within the thread. Okay. Again, I think it's going to be a really useful tool for us, especially in this online modality that we're doing the course. But again, something to try, okay? Good question, Richard. I basically don't care. I will say the following. So the advantage of the forum versus asking questions specifically by email are a couple. So number one is everyone will see the questions. Maybe someone will help as well, and that is more than welcome. If you guys know a source or know a different way to approach things, it's always welcome to have a variety of opinions and comments. So that's a plus there. The other thing that you need to be aware is that everyone will see that. So with that in mind, what I will say, if it is something very specific, so today we are going to discuss the first assignment. So if there is something very specific to your implementation, maybe it's better to ask by email because either you don't want to expose your implementation or it's something very, very specific. But in principle, I don't really have, other than that, I won't have any preference about that. Okay, but that is a really good question. All right. Okay, any questions so far from class number 1? So we went through the very basics so far at that point, and we just reviewed the type of objects that you can find in R, or variables as we call it. And what we're going to discuss today is functions. And function is one of the most important things in R and in any programming language, because it's at the core of modularity. And that is a very, very important concept that we will be discussing not only today, but in the coming lectures as well. So the idea for today is we will talk about functions, what they are, how we define them, arguments. That's also super important. It's also part of this very strong and powerful technique. Then something which is a bit of a caveat and something that we should be aware, local versus global variables, and we're going to see what is that, returning values, and then some examples. Okay, and by the end of the class we will be discussing the assignment, which will be mostly based on today's lecture and last lecture. So what is a function? So a function is nothing else than a collection of commands, like lines that we execute in R, that they are bundled together into a single unit. The main advantage of this is, imagine that you get data. I think I mentioned something like this last class. Imagine that you get data from the lab, or from your experiments, or from a collaborator or a simulation. It doesn't matter at all. You have the data and you need to proceed in analyze the data, in produce a plot at the end, in do some statistical analysis, in do something, and you have to do it several times. If you find yourself typing many times the same commands over and over, that is just, as I mentioned last time, a waste of time. It's error prone because you can make typos in the things, you can implement things wrongly, and that will be just not good, right? So instead of that, you have a unit that you can reuse many times, and in that way that helps basically everyone. It helps you to be more productive. It helps the debugging process, the process of analyzing if the results that you are getting is correct or not. Now, one of the key elements for allowing this is to pass this new information into this unit, and the way to do that is what we call passing arguments. So those are, like I like to say, if you have a unit, think about a room in your house. The arguments are the doors or the windows into your house that you can pass things into. Now, when I had to return something from the function, when I had to obtain the result, that's what we use return value. And that has to be very explicit. And that's something that I'm going to be pushing you a lot to have explicitly, because R does some things by default, but that is not what we call best practices, because in some cases can fail. So if you don't say anything and you do a last computation, or you print something at the end of your function, R will take that as a return statement. Not as a return statement, but actually as a return of whatever computation was done. And you can use that if it was a return statement. I'm going to show you an example to be more concrete, but I just want to warn you, this is something that is not really good to do. You need to be specific and explicit about what are you returning. Okay? There are many built-in functions in R. We saw some of them last class, type of, str for structure, print, list, many more. So what we are going to do is we're going to be able to create our own functions with a specific functionality, with a specific capabilities of doing something, depending on what we want to achieve. Do we need to do this? Yes, we do need to do this. So we have seen, for instance, in researchers or students before, people with thousands of lines of code, where basically you have like 10 times repeated 20 lines of code. And that's what we call copy and paste code. And that is just not right. That's again, is making you waste your time, is very inefficient in the point of view, or from the point of view where if you had a typo or an error in one of these 20 or 10 lines that you are copying all over, then it's impossible to track all the errors that they can be basically copied over because of pasting and copy. So instead of that, we're going to create functions, and we're going to keep reusing these functions, and we're going to give the functions all the flexibility and all the options that need to have in order to make it make them generic enough so that we can keep using it. If you are really into programming and you are how to say this, if you are developing a particular project that you think is really good, and this I have done with other students and myself as well, what you can then do is grab your functions, create what we call a library or a package in R, and actually publish that in the current repository, the one that we were talking last class. And that is really nice, because first of all, is R, as many other languages in nowadays, is following this trend or this opportunity, I would say, of open sourcing things, basically allowing anyone to see your code and to contribute to your code. By doing that, you do, in what is my humble opinion, a more fair science. And also, you expose your code a little bit, so people actually can look into your code and sometimes contribute and tell you, oh, by the way, you can do this more efficiently, or by the way, this is a typo or a bug, and things can improve. So it's about this open policy, but also about collaborating and contributing to the community, to the R community in this case. But in any case, that probably is a topic for later on. And again, if someone is interested or there is a general interest on that, that's something that we can cover in one of these 2 or 3 lectures that we have still not decided the topic. By the way, I forget to mention this at the beginning, I'm sorry about that. From what I have in the survey, 50% of you decided that the best spot for the office hours is Mondays from 1 p.m. to 2 p.m. Okay, so in principle, our next office hours will be next Monday. I'm going to be sending an email probably before or during the weekend, just about that, and we will be using Zoom, probably the same meeting. We will try to have the conversation just with everyone speaking up, and if you guys prefer, with the cameras all open so we can see each other. Okay, so I mentioned this a couple of times already. All this is about modularity. Okay, and I mentioned this example in particular. If I have a duplicated piece of code all over my main code, basically it's very difficult to track any errors that could be part of this code. But however, if you have these units, these functions, it's way easier to check only one replica of this code. And what is even more interesting, you can reuse it as we mentioned, but also you can test it individually. And that is something that we're going to be covering probably not next week, but week after. So it's called unit testing, because you take these units, these functions, and then you run different cases where you know or you expect to have a particular result, and you know if that result doesn't match your expectations, then something is wrong with the code. Okay? In a nutshell, what modular code means is a code that stands by itself. Only depends on other functions that can be part of this module and can be tested by its own, basically. Okay, outside the whole program where it is used. All right. Any questions so far? I don't see any questions in the chat. Okay. So I had to mention this because this is one of the main elements that we're going to use to create functions. On the next slide, we will just jump into that. Is what we call code blocks. Okay. And code blocks are defined by these 2 curly braces. Okay, so when you see one of these, it means there is the beginning of a code block and the ending of the code block. What a code block means is a chunk of code, several lines of code, which can be used as a body of a function, as a body of a for loop, which we're going to see next class, that are executed all together. Okay. And we will see an example of that. But basically, you can take this for now as the beginning and end of the definition of a function for today's class. Okay, it's more generic because, as I say, it can basically, in a bigger program, in a bigger code, it can define sections that need to be executed all together. This is important, and this is one of the things I'm going to be looking in your assignments, and I'm going to show you examples about this. It's important that you indent your code blocks, and I show you in a second what I mean with that. But basically, every time that you have one opening curly brace, you will press the tab key or leave 4 or 5 spaces, so you can very easily see in the code how the code flows. Okay, it's not important for the computer or the program in this case. However, let me tell you, if you were programming in Python, this is mandatory. And it's mandatory because they want to stress so hard how important it is to be able for the programmer to see that. Okay. Again, I'm going to be looking for this, and I'm going to penalize you, in your assignments if you don't have these indentations every time that you have these code blocks. Okay. We're going to see this last point in the examples, but basically, where do you start or close the curly braces is kind of relative in the sense that there are different conventions. What I'm looking for at this point with the indentation and the curly braces is to be consistent. So if you indent in a particular manner at the beginning of your code, you should be indenting in the same manner at the end. Okay? So, first example of a function. Okay? That's the definition on the right. Okay? So this is my func. That's the name that will have my function, followed by the assignment operator, this left arrow that we discussed at class. This is a keyword, a command in R. It's called function, open and close parentheses because it's a function itself, opening curly braces, then something, closing curly braces. So this opening and closing is what defines my function itself. So whatever goes inside there is what this function, my func, is going to do. In this case, I'm going to use the cat command. I think I mentioned this. I don't remember if we saw an example, but it's very similar to the print command. The main difference is that when you print something in the screen, it doesn't put this bracket 1 notation. And because it's a function, open parenthesis, close parenthesis, then hello adoring fans, and -n. I believe we discussed the -n. That's the new line code. So all what this function is going to do is going to print in the screen hello adoring fans when I call it. Okay, now couple of comments. You notice these plus signs here on the left. You don't need to write that when you are typing the function in R. Okay, that is something that R does automatically for you. Okay, so I'm just putting this there to give you the context. So if you were typing this, you will type my.func, left arrow assigning operator, function, open curly braces, hit enter there, and the plus sign will appear automatically for you. Again, super important. The first time I look at the assignments in this type of courses, I see people coding this plus sign and the functions will fail. Okay, so this is a continuation of the prompt where R is telling you I'm still expecting input from you. Okay, again, this is the very first function we're going to write. You can follow the example on live if you want. But this is not the typical way we will do it, and we will see this by the end of the assignment of the class and how you will do it in the assignment. Now, if I just type, so let's say I define this function, I type it all this, okay? If I just type the name of the function, my.func, what I will tell you is, okay, this is a function and this is the content. This is what the function does. It doesn't execute the function. So a couple of terminology issues here is, writing the function, specifying what the function does is what we call defining the function. Okay? Writing the name without the parentheses, notice that, remember all functions in R has to come with a parenthesis, just shows what the function or how the function is defined. If you want to use the function, and use the function means calling the function, executing the function, invoking the function, all these are synonyms for calling the function. If I want to execute the function, I just type my.func, parentheses, no arguments, because if there were arguments will be defined here, but there is no information communicated into this function, enter. And then you see in the screen, hello adoring fans, what is what this function is supposed to do. Okay? Very simple, almost trivial example of a function. Any questions about this? I cover a couple of very basic but very important points. How we define a function. If you are writing your function in the R terminal, you expect to see these plus signs every time you hit enter. It does not mean you need to write these plus signs when defining the function. Okay? And how to call the function or execute or invoke the function by just typing the name of the function, open and closing parentheses. Okay? Okay, so that was our very first function. Very simple function, I would say. Not much excitement about that. So let's try to do something more meaningful, something more interesting. So I'm going to define a function now that it will receive one argument. And as we were saying at the beginning, an argument is a way, a door, a window to communicate into the function information from the outside. Okay? In this case, the information is communicated through variables. So let's say I want to define my print.me function. So print.me function, left assign operator, left arrow assign operator function. And then between the parentheses of the function, I'm going to write a variable name. In this case, my variable name is A. I open my code block, close my code block, and then what the function does is it's going to take whatever was passed into the function and print it in the screen. Okay, so if I do print me 10, in this case 10 is the value, will print 10. But if I want to pass a variable predefined, I can say, okay, D, let's say D will have the value of 11, so I'm assigning the value of 11 to the variable D, and then print me and the name of the variable, D in this case. So the print me function that we just defined here will take D equal 11 and just print 11. Okay, any questions so far? I know this may be too basic, so let me know if you guys think this is too basic, this is okay. In the comments, that's all good. I just want to know, it's hard for me to read usually when I teach this class and I can see your faces, I can see if what I'm saying doesn't make any sense at all, or if it is super boring, or if I should go faster or slower. But here there is no way I can see that. So please let me know in the comments if this is too obvious, if you guys got all this, or if there is something that is not clear at all. Okay. So we had our definition of myfunc before, where basically we say hello adoring fans. Now let's say that I want to do some computations inside my function. So we saw how to pass arguments into the function in the previous example, but that argument could be anything. Actually, in my print me example, I could write hello here and say print me hello, the string hello, and it will just print the string. But what happens if I want to, for instance, say compute something and do something? So I'm going to do my func calc, it will compute something, it will receive still one argument A, and inside the function I'm going to perform a couple of calculations. And notice that the curly braces that we were talking before defines several lines here. So that was the main idea of the code block, right? That you can have several lines of commands that are part of this unit, in this case, this function definition. So in this case, inside the function, I'm defining B that does 2 times A minus 7, and then D, which prints A times B. So A was the original argument, and then prints the result, okay? Now, one important thing, and we're going to come back to this, is whatever happens inside the function remains in the function, unless you communicate that information out of the function. Okay, so what I mean is these variables B and D that I'm defining here inside the function only can be seen from within the function. If I ask what is the value of B outside or D outside of the function, they don't exist. So R will return an error saying I don't know what B or D are. Okay, so one more thing I want to mention now is what happens if we want to have multiple arguments. So we saw two examples now of having one function with one argument, in this case the variable A, but we can have multiple arguments. The way to have multiple arguments is to put a comma after the name of the variable and continue with another variable name. So for instance, this printme2 function, what does is takes 2 arguments and it says A was or is whatever value, new line, B is whatever value was entered, new line. So if I say print me 2, 3, 4, then the function will say A is 3, B is 4. Okay. Now, this is very important as well. If I say print me 2, 6, I only passing one argument into the function. This function because it has A and B, is expecting 2 arguments to be received. So that will end in an error message saying, error, I don't know what B is, so when you try to execute B, when you try to execute the second line, and the function goes and looks for the value of B, there is no B defined. So it says argument B is missing with no default. Okay? Is this clear? Or at least makes sense? Trying to see if I can see the chat. I think it should. Okay, so we have, sorry, I was expecting to see something pop up. Can we write all functions in one line to avoid plus sign? You could, but I will strongly recommend against doing that. And the reason is clarity. Okay, so if you are trying to follow the example and you can just write the function in one line, you can put semicolons after each of the things, but I will strongly recommend against doing that for clarity's sake. Sure. Can you explain one more time which one? This last example with the 2 arguments? Okay, perfect. So the previous example, we have just 1 argument in the function, right? The argument A, either for when we had the calculation or when we had the first version of print, right? So we were expecting just 1 value communicated into the function. In this second version of the printme, I have the argument A, and then because I put a comma, B, the function is expecting 2 arguments. The problem here is if I don't pass these 2 arguments into the function, when this line is executed, the function will not, sorry, I was trying to, well, you can see the plus. When this line is executed, you cannot find the value of B unless something was written here, okay? And that's why the function fails here if I just write the first argument. Now, there is a way to fix that, and we are going to see that in a second, okay? But the reason why this function is failing is because the function was expecting, by its definition, was expecting to have 2 different pieces of information coming into the function. Okay, and it just failed because in this second case I just brought 1. Okay, did that help? Okay, perfect. So I just mentioned this, no problem. I just mentioned this because the second thing, or one of the other important things that we are going to see in our functions, is to have default value. So we were discussing the example just a second ago of having 2 arguments, 1 was missing and the function failing. So you may want to have in some cases either a protection against this, or maybe the function not failing if that argument was missing. So how we can achieve that? Well, this is a key part of functions definition, is passing default values or defining a function with default values. So this is our 3rd version of the printme function. Okay, so the function will still receive 2 arguments, but notice that now B, so I have function A, comma, and then B is followed by the equal sign and then a given value between quotation marks, and in this case I pick a string, okay, pants. The function definition inside is exactly the same as before. Cat A is A, new line, cat B is B, new line. Nothing changed here. Whatever changed was just in the definition, in the first line of the function, and I just add B equal quotation mark pants quotation mark, meaning that B is defined as a string now that has the content of the word pants. Now, if I call my function printme3 5,6, it will just, because it has the value of A being 5 and the value of B being 6, it will say A is 5, B is 6. I can call the function in this way. Because the function is defined with A and B, I can say printme3 7, B equal 8. That will be exactly the same as calling the function printme3 7, 8. And then it will say A is 7, B is 8. Okay? Now, this is the interesting part. This case, printme with just 1 argument was failing before, and it was telling us B was missing. With this way of defining the function, with basically providing a fallback mechanism for the function to find a particular value of b, then if I just use one argument, the function will go and grab whatever I wrote for b here in the definition of the first line of the function and use that as the fallback value of that variable b. So in this case, when I say print 3, we'll say a is 3, b is pants, because it's what I wrote in the definition of the function here. Okay, this is a very, very important concept. Something else I forgot to mention is the way that the function assign the values to the variables that are part of the arguments is positional unless that you specify the name. What it means is if I write a first here and then I write a number here, that value corresponds to the first variable passed. The second value corresponds to the second value or the second variable defined in the function. Okay? Okay, so yes, that's a very good comment, Shender. And we're going to see an example of this in a second. Okay, what happens if you print me 37,8? Okay, what will happen is, because you are specifying the name a here, which is one of the value of the variables defined in the function, R will go and grab a equal 8. And then the second value, because there is only just one more argument in that function, will be used as b. So that will work. Okay. In some cases, you want to be explicit about the names. In other cases, because you want to keep it general, you don't specify and just use the position of the arguments. Okay. That's a good question. Okay. And I'm taking just 1 second here to see if you guys have any questions about this, because again, this is probably one of the most not difficult, but sometimes, what to say, a little bit confusing points in functions definition. Okay, is it possible for functions to use variables you define outside and before your function and not specify as a function parameter? I'm laughing because I'm going to talk about this. This is a little issue, but I know this is different for some languages. So, the answer is yes, it is possible. But it's very, very strongly and highly recommended not to do that. And I show you a couple of examples. So this is going to be part of some of the discussion we will have today. This goes by the name of global variables, and this is really bad. And it's really bad for a couple of reasons. Okay, so it is possible. It's true, it depends a lot on languages, and R somehow allows this in different ways, but again, it's strongly disencouraged to do this. And to be completely clear, if I see this done in your assignments, you will be penalized. You will lose marks because of that, and there is a reason. It's not for me because I'm just stubborn. I'm, but it's not that the reason here. There are ways you can break codes very badly by using this particular way of doing things. Okay. So let me see. Okay, here we go. That's exactly what the question is, or the main topic behind this question is local versus global variables. So, and this is the point. Where these variables are declared matter at all. So declare is another word for defining the variable for the first time. So let's take this function, for instance, the function g. Very bad naming, okay? And the function g, what it says is nothing. It's just defining b equal 10 inside the function, okay? So I execute, I'm calling the function g, and what this function is going to do is just going to define the variable b inside the function. Now, I execute the function, and then I ask, what is the value of b? Okay, and R says, I don't have a clue of what b is. Okay, object b not found is the formal way for R to say, I don't know what b is. Okay, what this silly function is trying to show is whatever happened inside the call block here, the definition of b remains inside the function itself. I mentioned this some few minutes ago. The variable only exists within the call block of this function. Okay, it's not as if I was defining b equal 10 outside and then asking for b again. Okay, This is, formally speaking, known as the scope of the function. Is the realm of existence of the function. So whatever happens inside the function remains inside the function. And that is why it's so crucial. And I know, it may feel like really that requires a lot of effort to passing information outside a function and then communicating the information from the function to the outside world. But there is a reason for that, and I'm going to cover that in a few more minutes. But this is just to show you that whatever you define inside the function, unless you pass that information outside, only remains inside the function. Okay? So this is a local variable. Now, look at this example. It's the same function, didn't change anything. I just put it here for reference. So I'm going to call b pants. So I'm going to assign the value of pants to the function. Function say is the same as before. I call or execute the function, and then I ask what is the value of b, and b is still pants, even when the function sets the value of b to 10. Okay, and again, so there is a copy of b, or there is a variable b defined outside the function and a variable b defined inside the function. Okay, so let's see another example. So in this case, we have another function. I think it's similar or very similar to the ones we saw before. Print a, and now the function takes one argument, and a is added the value of 3, and that's the value of a, and then is printed inside the function and a new line, and that's it. That's all what the function does. So in this case, I'm going to set a to 10. Okay, we define this function, and then I'm going to call the function to execute print a, and then a has the value of 10, so it comes inside the function. 10 plus 3 is 13, so the function ends up printing 13. Okay, and now if I ask what is the value of a is 10, because it was only assigned to 13 inside the function. Okay, is this clear? So again, this is important because I have a variable called in the same way inside the function and outside the function, but it's like there are two different words. The word outside the function where a is 10 and nothing had changed, and inside the function a is 13. But because these are two different scopes, that's the scope of the function or the scope of your session, then there are two possible values or two different values for a. Okay, so this is an example. So this is basically the same example as before. Now this is it's more of a suggestion than anything else, but this again, it depends. I won't be so harsh with this. A better way to implement this is to say, okay, a is 10, this is the previous definition I showed you, and then because I'm assigning something into a variable, use a different name for the variable that I'm printing. Actually, because this is so simple, you could just do cat a plus 3 and then a new line. But again, this is just for clarity's sake than anything else. I mentioned this the first class. Sometimes we just think that programs are for the computer to understand, but it's very important that at some point we are clear about the way that we write the programs, so the human behind writing the program or reading the program can easily follow what the program is trying to do. Okay, so this is another example, a little bit more convoluted, I would say, than the previous one, because in the same way that we define functions, we can define functions inside functions. So, and this is again to exemplify the scope of these functions. So we have what we call an outer function that does not receive any arguments. Inside that outer function, there is the definition of a, which is 20. And then there is the definition of an inner function, an internal function to the outer function, that assigns to a 30, prints a new line, and then we end the call block. So that's the first definition or the ending of the definition of the inner function, of the internal function to the outer function. We are going to call the inner function and then print a. Okay, so one function here, outer fun, and then inside the function and another internal function, inner fun, which in both cases is using a as variables. And again, this may be considered bad form because it can be confusing for the person reading this code. But this is an example that tries to show that in particular, so it's to exemplify that. So it's an example that shouldn't be followed, in other words. So what I'm going to do at the very beginning, before calling the outer func, is to do a equal 10, then call outer func, and when I call outer func, this is what is going to happen. I'm going to define a equal 20, the inner function is defined, then the inner function is execute, where there is the definition of a equal 30, so it will print 30, then the end of the calling to the inner function is done, and then I print a again with the value of 20, and that's why you get 20 here. If I ask for the value of a after the outer func has finished, a is 10, because that's the value that I used to define here. There is one more important thing to understand here is, if I call inner func directly, R cannot find this function because it doesn't exist outside the scope of the outer func. Okay? Any questions about this? I know, as I said, this is a little bit convoluted example, but it tries to touch upon all the points I was mentioning before. Local scope, local variables, and internal functions that are not accessible from the outside of the scope of the main function. In any case, feel free to ask questions about this if something is not clear, or come back to you. Okay, so we were talking about this global versus local variables. So variables which are declared within the function are called local to the function, and they can only be accessed within the function. Variables which are declared outside the function are usually referred as global, and as I say, and as you guys were realizing as well, this is not a very good idea. It's the real good way, or the proper way of doing the communication between functions and variables outside the function is through the arguments. And I tell you explicitly why. So imagine that you have this awesome function that does an amazing statistical analysis, and you want to share with your collaborators or with your community, I mean the research community you work with. And now your function has 10 different variables, and they are called in a very particular manner, because for you makes sense when you were writing the functions to call the argument 1 x1, argument 2 yz10, and argument 3 x11, and so on. So if you don't allow the function to receive arguments in the way that we have seen before, now the user that wants to use that function has to exactly call in the same way the variables that you are going to use inside your function. x1, xyz not, x110, whatever you decide to call those variables inside your function has to be matched exactly with the way the user that wants to use your function is going to call it. That can be really, really stressful, let me say, for the user, because you need to be very precise in the way you call your functions, and also the way you name your functions may not make sense to that person. So instead of that, if you pass those arguments, those positional arguments in your function, the user just can call the variables however he wants or she wants, and then just put in the corresponding spot of the function. Okay, so in that way, we allow to have way more flexibility, to have the function being more generic, and I would say more powerful in that way as well. Okay. The other thing that is really bad about global variables is if you use these global variables inside your functions and then you have a typo, a bug in your code, you don't know where it's coming from. It's very difficult to debug a function that is using global variables, because any other function, any other thing you do outside this function can change the value of that global variable. So somehow you are losing control about what happened to those variables. Okay, so that's another really important reason why not to use global variables. So this is an example of how you will use a global variable. So again, I should put a big red band here saying don't do this. Okay, it says here wrong, so don't do this. So this function print b doesn't receive any arguments, but it refers to a variable a, and then it's very similar to the previous function where we basically use an argument here a, but here we are removing that argument. So I define this function, and I define a to be 10, so if I do print b, then it prints 13, because it goes out of the scope, it grabs the value of 10, substitute here, add to 3, and print 13. Okay? Again, this is bad practice. You're going to be penalized in your assignments if you do this in this way for the reasons I just mentioned before. Instead, what you should do is pass an argument into the function a, and now you can say print b2, the second version of the function, with the variable that you want to use. Okay? So an example of how you shouldn't be using global variables here. Okay, let me know if you have any other questions. And by the way, I didn't mean to say, okay, this is, I mean, it's not the proper manner, but the question was perfect, okay? So I don't want to disencourage you of asking this question, so please. So again, this is an example. This will come back in not this assignment, but in future assignments, how to read data properly. And again, this is a reason, in some way, this function here, my bad analysis, is reading data in a global manner, using global variables. So what I'm doing here is I'm loading my data from this CSV file. Read.csv was a function we discussed last class for accessing data from CBS files. And this is the name of the file that I'm reading. So my bad analysis function doesn't receive any arguments. So always when a function doesn't receive an argument, it can be suspicious. It doesn't mean that functions always should have arguments, but 97% of the cases, a function needs an argument. And so this function doesn't receive an argument. It takes my data, one of the columns of the data, and then calls another function. Doesn't matter what it is. So it's doing some statistical analysis or something. The correct way of defining this is, say, function, what is the input data I want to use, select the column from that input data and do the analysis with that column, refer to the input data. So the main difference between these two functions is the argument that I'm passing into the second function. Okay? So in that way, when I call my good analysis function, I specify the data I want to use. This function is way more generic because I can use it with any data that I have read from a CSV file, instead of needing to call my data explicitly in the way this other function is doing. Okay, again, another example of how to use local versus global variables, and instead of global variables. Any questions about this? Okay. So this is the final part in functions definition, the one that we haven't seen so far, but again, is super important. And it's a return statement. So we have seen how to communicate information into the functions by using arguments that go inside the functions. Those the things that we put between the parentheses here. We have seen how to define arguments that takes default values if the user has not specified a particular value. And now what we want to know is how to obtain information back from the function. So in that way, we can complete the circle of communicating communicating information into the function and getting information back from the function, because we saw that the variables that we define inside the function remain inside the function and cannot be accessed from outside the function. So the way to do that is to use this keyword return. Okay, so I have a function here, double vector, that receives one argument. It computes twice the value of the argument and returns the value. Okay, so in this case, double vector 10, what I'm doing is I'm assigning to the variable y the value that the function is returning. So in this case, if I use 10, it will say 10 times 2, 20, and it will return the value 20, which is actually assigned to the variable y. So in that way, I do this, function doesn't do anything other than computing that and putting the value back into the variable y. And so when I ask for what is y, it's 20. If now I ask double vector of y, which was 20, and I do not assign the variable to anything, the value is printed to the screen because I'm not assigning that to a particular value. Okay? Any questions about this? So all what the return statement does is it takes a variable that was computed inside the function and allow you to capture that value in a new variable or in the screen if you don't assign it, so the user can be aware of what is the value of that. Okay, super powerful. Again, 90% of the functions will have a return statement. Okay, So just to show you the difference here, I'm going to define a double vector 2 function, which is exactly doing the same computation as before, but instead of assigning to a variable and returning that, it's just doing x times 2. So if I run double vector 10 as before, I get 20. Okay, and if I run double vector 2 10, I also get 20. The main difference here is this behavior that I told you R has, that if it finds you doing a computation and not doing anything else after, it will use that last computation as your return statement. This is very bad form as well. This is not good. And again, if you have to return something in your functions, you must use a return statement. Why am I emphasizing this? Well, first of all, it can be that you just don't want to return that computation you're doing. This function is very simple, it's one-liner, right? But it could be something more complicated, you were testing something and not necessarily want to return that. So it's basically doing something by default, and when you're programming, you would like to have everything under your control. So the return statement is a way to explicitly say, I want to return this value for the user. So that is one of the main reasons why we need to have these return statements. The other reason is that in some cases this may fail. Okay, depends again the complexity of the function. So having the return statement explicitly is a way to be sure that this is what the function is going to be returning. Now, something very important to know about the return statements. As soon as you hit the return statement, the function is finalized, and that's the end of the function. So if you have any lines after return, they won't be executed. Okay, so usually your return statement, and this is not 100% true, but usually most of the cases your return statement is your last line in the function. You may wonder where this is not true. Well, you may have conditionals, which we are going to cover next class, so you may have different levels at which you will execute the return statement. Okay, but usually in the functions that we're going to be working for the assignment this week, your return statement should be the last line, and I'm just letting you know you should have return statements. Okay. Okay. This is another comment. In the same way that R uses the last computation as a return statement, it uses print. It can be used print as a return statement. So I'm not going to go much into the detail of this example. You can look at it. And the reason is I don't want to look at it in detail because I don't want you to do it. I just want to let you know that some people use print as return statements. And again, this is bad shape, bad practice. So if I see a print instead of a return, you're going to lose marks again. And the reason is, well, the same two reasons I mentioned before. The return statement function, its whole goal is to return something. The print function is to display information in the screen. So if you are capturing that information with a variable, then R will print in the screen and put in the variable. So it's doing two things, in particular one that the function print is not aimed to do. And in some cases, depending on the type of data you're returning, this may fail. Okay, so it's a way to try to mitigate those points of failure that can be present if, in some cases, if we don't use the functions properly. Okay, so whenever you need to return, bottom line of this is whenever you need to return a value from a function, we use return. Right? So this is a general comment, and then I'm going to show you an example or two, maybe, of how we are going to actually do all. I have been showing you example of functions, but I want to show you how the gymnastics, the actual procedure of creating a function and loading a function will go. How we save functions? We save functions in plain text files. What this means is no Word files, no HTML documents, no files of any fancy style. Okay, they have to be plain text files. Otherwise, R will not understand them. Okay. So usually you may have typed the functions we saw today in your R session if you were following online the examples. Usually it's not the way that we write our functions. We open a text file, a plain text file, empty, and we start typing the functions there. Okay. For that you should use a text editor, or even better, a code editor one. Sorry, good options are Sublime, Atom, or even the R editor that R brings along. So I will show you the example of how to do that with R actually, but I have heard that Sublime and Atom are really good options. So maybe someone else know different ones or are using different ones. I know RStudio has its own, so please feel free to suggest something either in the chat or in the forum. That would be a good idea to share something you guys know about a favorite code or text editor that you can use. After we write this, after we save our functions in a file, what we are going to do is we are going to load them into R. And for that, we are going to use what is called the source command. Okay? So, for doing this, what we need to do, this is the procedure I propose you follow, but of course, if you have experience doing that or you find a different way and it works, it's just fine. What I'm going to show you is, okay, I'm going to create a folder or a directory in my desktop, and I pick the desktop because it's a place that everyone has in its own computer. So I'm going to pick the desktop and then create a folder BCH2024. Okay, and then in RR you can change the location. This is very important. You need to be placed in the right spot to find your functions. Okay, so it's like finding a file in your computer. So this is what I'm going to do. We go through this and I show you how to do it in R. So first we are going to create this folder. Then we are going to change the location into this folder. So one thing I want you to notice is this tilde symbol here represents your home directory. So let me just open R here for a second. I had too many screens here. I'm going to launch R. So I invite you at this point to do this because again, this is going to be very important at the point when you're going to create or work in your assignment. Okay, so I'm going to share now my R session. So I hope that you guys can see my R terminal now. Let me know if you are not able to do so. Okay. And I'm trying to keep an eye in the chat, so if someone cannot see my R terminal, please let me know. Okay. So I'm in R now, and what I'm going to do is I use this command dir create. So this dir create is like when you are in your browser and your file explorer and you do new folder. And now what I'm going to type is this tilde symbol. It's usually on the very upper left of your keyboard, next to the one key, and it's usually you press shift to get that. Then I use the backslash, and then I'm going to say desktop. Okay, and one thing I mentioned is that you can go up and back with upper and lower arrow in R for the history, but you can also press tab to complete things. So for instance, I type DES and then press tab and R suggests desktop there. And then I'm going to write BCH2024, the code for our course. Yes, it's the same for Windows and Mac. So if you open the R console in either Windows or Mac, in both cases, this should work. Okay, if you find that it's not working or giving you an error, just let me know. And same for Linux. I think we had at least someone using Linux. And then I will hit enter. Okay, and as you can see, nothing changed, nothing or there was no message associated. Okay, now that what did is you go to your folder, you can check there is a new. If you go to your desktop, sorry, you can check there is a new folder called BCH2024. Which will be empty. Now if I use this function get working directory and I press enter, it says, oh, you are positioned in users Marcelo. What it means is whenever R is going to look for files or functions, it's going to be looking inside this folder, this directory, and I'm using directory or folder as the same thing because they are. But instead I want R to look inside this folder that I just created. So what I'm going to do is, and look, I'm pressing up arrow here, I'm going to go back to my dir create command, and I will substitute that for set working directory and hit enter. Nothing appears to have happened, but if I use my get working directory and you notice that I circulate to my get working command with the upper key, press enter, now it says users Marcelo desktop BCH2024. Okay, this means that I now position it in that directory, right? There's one more command I want to show you, the dir command. So if I do dir, it says character 0. That's a way for R to say it's empty. So it means in that directory there is nothing defined. Okay? So 1 minute, we're almost at the end of the class, and we're going to take like probably 5 more minutes because I want to show you this in very detail. Any questions about this? Anyone having trouble with this? By the way, this will be part of the recording, so you can go back and try it again if you want. Okay, so next step. I'm going to open, and again, you can do this in different ways. What I'm going to do is I will open the document editor in the R console. You probably see my icon there. I'm going to click on that. This will pop up a new screen. Oh, sorry, that's not the one I want. I think it's this, the one saying create a new empty document in the folder. Okay, so I'm going to click on that, and now it will pop up a new screen that I will share with you in a second. So new share, I had to use that one. So now you see a new window, completely empty. Okay, and here is a text editor that you can use. It's a code editor provided by R. Okay, so what I'm going to do here is I'm going to define my functions. So I'm going to start with a comment. So hashtag, and this is an example of how to define functions. Okay. And then I'm going to proceed and define a function. So for instance, I'm going to define a function called log.apps. That's the function I'm going to define is a function that is going to take the absolute value of an argument that I'm going to pass and compute the log of that. So my function will receive an argument collects. Now I'm going to open, and you can see the editor is opening and closing my code blocks, my curly braces automatically, and hit enter a couple of times. The reason for that is I'm going to say what the function does. So this function computes the log of the absolute value of the variable x. Okay. And you can see the editor is also indenting for me already the code. So what I'm going to do now is I'm going to say the result is going to be the log, and that's the function you want to use to compute the log, the absolute value of x. And then at the end, so basically here we do our computation, and notice how I'm commenting the function. So that's something I expect from you to see. And then return, I'm going to say return the computed value. Okay, and now I use return of result. And this is a very simple function. Okay, so now what I'm going to do is I'm going to file and save as. So a new window will ask, and I'm going to call this myfuncs.r. Okay, and I'm going to pick, so by default you're going to try to save this in documents, but now I want to say go to my desktop. Okay, there should be a BCH2024 directory there, and save it there. Okay, it's very important you select where you want to save your function. Okay, so my function is saved. You can see that in the title of the editor. I'm going to go back to my R console now, and I'm going to say dir, and now you can see that instead of saying character 0, now it says myfunc.r. Okay, so the next step is loading the definition of the function in my R session. So for that I'm going to use source and the name of my file, and I can press tab. I type my and then tab myfunc.r, hit enter. No errors were detected, so that is a good sign. And if I want to be sure that my function was loaded, I can use the function ls. ls, open and closes parentheses, and now it says log apps, which was the name I gave to my function, is there. If I do log apps, it just shows what the function does. It shows the definition of the function, it shows the comments. If I use log apps, then it computes the absolute value and then the logarithmic of that. This, by the way, is the local, is the natural log. So if I want to get, like for instance, the log apps of 3, and I take the exponential, then I will get 3, because basically it's the inverse of the exponential. And by the way, I'm showing you a couple of different functions that you can use in our mathematical functions. okay? The good thing of this function is if instead of writing log of 10 I write minus 10, usually that fails and gives you an error message. So that will still compute it because it takes the absolute value of that. Okay? Any questions about this? So this is what part of what you will have to do in your assignment. So it's very important you go through this maybe again after the class with the recording, but this is a crucial part of defining your functions, writing for functions, loading the functions, and executing the functions. Okay, so let me go back to the slides. We are almost at the end. So this shows basically the procedure I was describing. In that example, I created two functions, one that was log square, which basically instead of taking the absolute value was taking also the square of that quantity and then doing the same thing. But that's basically the same idea. Okay. Let's see if there are any questions in the chat. I think someone was commenting that the Visual Studio Code editor is really good. So again, that's thank you for sharing that, and I invite you to maybe I start a thread in the forum asking, okay, please share with us your favorite text editor or code editor. That would be very nice. Okay, so a quick summary of the functions. They are crucial in modern and modular programming. They are a cornerstone in reusability. They are mandatory for our course, but for coding in general, I would say. They should, and in most of the cases, have arguments and return. These are a list of useful functions that you will find yourself to positioning in the right spot for saving your functions and loading the functions. What I expect for you is to have proper comments and style in your functions. In this case, indentation, minimum variables names, the same way I did in the example. Write your functions using a text editor, not Word, please, or any other kind of word processing program. Source your functions using the source command, and now be aware of the difference between loading, writing, or defining a function and executing, calling, or invoking the function. Okay, that's mostly what I have for you today. The only thing that remains for me is to show you the assignment. Okay, so let me share with you now. The website. So I hope that now you can see the course website. And if you look into assignment, there is assignment 1, which is about functions. Okay. So first thing that you need to do is start by creating a file called myfuncs_assign1.r. And what I would recommend is that you create, in the same way that we created this BCH2024 directory, I would recommend that you create a subdirectory under there or a folder inside called assignment1. So you can keep all your assignments and submissions inside that directory. And so there are two functions I want you to create for this assignment. The first function is going to be called quadratic equation, and what it's going to do is it's going to analyze different properties, different quantities associated with the quadratic equation, our old friend ax squared plus bx plus c equals 0. So this function will receive three arguments, a, b, and c, and this is important, it goes back to our default values argument. We'll assume that if the user doesn't specify the values for a, b, and c, a is going to be 1, and then b and c will be 0. Okay? So function called quadratic equation receiving three arguments with a given default values, and then what the function has to do, it has to return a list, we saw this last class, a list containing the following things. Inside the list, I want a second list containing the coefficients of the equations, meaning the values a, b, and c that the user specified. The determinant of the equation, which is defined as b squared minus 4ac. Then a second list containing the two roots, which are given by the value of minus b plus minus square root of the determinant divided by 2a. Another list containing the coefficients of the first derivative of the quadratic equation, basically the values of 2a and b. And then a second derivative, which is the concavity in this case of the parabolic shape represented by the equation given by 2a. Okay? So, observations here. The function should return a list, which inside has another list, a value for the determinant, a second list, a third list, and a fourth value. So this is what we call nested list. Okay? Go back to our list examples. You will have to play a little bit. In particular, and you will see the output in a second, I want a list that has names. So the named list is what I'm after here. So this is an example. I'm calling my quadratic equation and assigning this to quad equation. That's a variable. And then I'm printing that. And what the outcome is something called equation with a equal 1, b equals 0, and c equals 0, because I ran with the default values. Didn't specify anything here. Determinant is 0, and then the roots, first root is 0, second root is 0, first derivative is 2, first coefficient of the first derivative is 2, second coefficient of the first derivative is 0, second derivative is 2. So that's the outcome, the output I was expecting. There are some comments here, mostly to tell you that you shouldn't be worried about dealing with cases with imaginary roots, meaning when the determinant is negative. Let's avoid these cases. And the other is test your function with known cases, like a0, b1, c minus 1, or a1 and c minus 4, which are things that you can basically compute on the fly, which are the roots and the other quantities. Functions that are useful for implementing this are the square root, the hat or double star operators, which represent taking square values, like 2 hat 3 is equal to 2 star star 3 equal to 8. And I think it's a very simple function. You will have to define a code block, you will have to define some quantities, and then you will have to create your list, which is the thing that you will return. Okay? So that's the first function. Any questions about this? Okay. Second function is based on one of my favorite recipes for bread, is the petit pain au lait. It's a French for tiny breads of milk. So the recipe has 4 cups of flour, 1 cup of milk, 15 grams of yeast, 2 tablespoons of salt, and 2 tablespoons of sugar. And this recipe, these elements, generates 12 pieces of the delicious French petit pain au lait. So what I want you is to create a function called petit.pains.au-lait, which basically will receive one argument, indicating how many pieces of bread you want to create. So, and based on that, it will take the elements, the ingredients, and calculate the right portions for the corresponding number of pieces of bread you want to bake. So if you don't use an argument, it will take by default the 12 pieces. So basically when you call, let me see if I can make this bigger, when you call the function petit pain au lait without any specification and you assign that to 12 pieces, the output will say recipe for petit pain au lait for 12 pieces, 4 cups of flour, 1 cup of milk, 15 grams of yeast, and so on. And it should say that the ingredients were computed based on 12 pieces. Okay. Now, you notice this function is printing the screen, but I'm also assigning something to this variable. So if I look at the structure of the variable I assign, it's a list of 5 ingredients: flour.cups 4, milk.cups 1, yeast in grams 15, salt tablespoon 2, sugar tablespoon 2. So this function is a very simple rule. You define these quantities and then you divide by the number of pieces that the user indicates. And then it does 2 things. It prints in the screen all this information, and then it returns a list with the values corresponding for each of the elements. Okay? I believe it's quite simple with the things that we discussed today. But you guys, let me know if you have any questions. There is a third part, which is testing your functions. So you will have to create in the same directory as before, in the same folder, a file called test_assignment1.r, and then what this file will contain is the following. It's basically sourcing your functions and then run all these test cases. Run the quadratic equation without arguments, write the quadratic equation for this case, the quadratic equation for this case, and then the petit pain au lait for these different cases. At the full case, 6 pieces and 20 pieces. Okay, so all this, basically all what you have to do is put this inside your test script, test file. Don't forget to source your functions, and then you can run this script and it will test each of your functions. Okay, any questions about this? I'm sorry I took a little bit longer. I think I spoke more than I was expecting. No, and so the question is, can we use for loops if we haven't covered it yet? And the answer is no. I don't really see how you will use it, and you don't really need them. So I created my functions, and I was trying to be sure that you don't need the for loop. Do you mean for the test cases, perhaps? It's not. So for the test cases, you could use for loops. That's right. But that's okay. I prefer to have the test cases actually explicitly stated. But for the functions definition, I believe it's not necessary at all. Yeah, I wouldn't use any for loops. No problem. As I say, I'm sorry I took a little bit longer than I should have. I will try to shrink. I usually tend to speak too much for two reasons. One, I want to be sure that you guys can follow and understand examples, and the other is I try to give you time to grasp the idea and ask questions. I will try to hold on that and on that trend I have. In any case, I will remain. We're done with the lecture today. I'm going to remain in the chat for maybe 15-20 more minutes if you guys have questions. If not, I invite you to use the forum, to email at courses@signer.utoronto.ca with the questions, and otherwise I see you on Monday in the office hours. Okay.